Hello and welcome back to Echoes Untold. We're your channel dedicated to uncovering the narratives woven into the fabric of history, stories that echo through time, waiting to be heard. We believe that understanding the past helps us navigate the present, and today, we revisit a moment that sent shockwaves through India and the global aviation community. Picture the early 1990s. India was on the cusp of significant economic change, and air travel, while not as ubiquitous as today, was a symbol of progress and connectivity. Into this era flew a new generation of aircraft, sophisticated, computerized, promising unprecedented levels of safety and efficiency. One such marvel was the Airbus A320. But on a day typically marked by expressions of love, Valentine's Day, February 14, 1991, of these modern jets, Indian Airlines Flight 605, met a catastrophic fate just seconds from touchdown in Bangalore. The incident was jarring. How could such an advanced aircraft, flying in good weather, crash so close to safety? It wasn't an act of terror or a clear mechanical failure mid-flight. It was a tragedy that unfolded during the most critical phase, the final approach. 92 souls were lost, dozens more were injured, and the crash ignited intense debate about the very technology designed to make flying safer. Join us as we take a deeper dive into the final flight of Indian Airlines 605, exploring the aircraft, the sequence of events, the complex investigation, and the enduring lessons learned from that fateful Valentine's Day. Our story centers on the Airbus A320-231, registration VT-EPN. This aircraft wasn't just new to Indian Airlines, having been delivered only about 2 months prior, in December 1989. It represented a paradigm shift in commercial aviation. The A320 was groundbreaking primarily because it was one of the first commercial airliners to feature a digital, fly-by-wire, FBW, flight control system. Now, what does fly-by-wire actually mean? In traditional aircraft, the pilot's controls, like the yoke or stick and rudder pedals, are physically connected to the control surfaces, ailerons, elevators, rudder, via mechanical cables, pulleys, and hydraulic systems. In an FBW system, these physical connections are replaced. Pilot inputs are read by computers, which then send electronic signals to actuators that move the control surfaces. This system allows for built-in flight envelope protections, preventing pilots from inadvertently stalling the aircraft or overstressing the airframe under normal law, and potentially optimizes flight efficiency. Alongside FBW came the glass cockpit. Instead of rows of traditional analog dials and gauges, the A320 cockpit featured multiple CRT, and later LCD, screens displaying flight information, navigation data, and system status in an integrated format. This was intended to improve situational awareness and reduce pilot workload, but it also required pilots to adapt to interpreting complex information presented digitally and interacting with the aircraft through flight management systems, FMS. The A320 was, by all accounts, a technological leap. Its safety record, up to that point, was generally strong, adding to the disbelief following the Bangalore crash. On February 14, 1990, VT-EPN was scheduled for the routine Flight 605 from Bombay, now Mumbai, to Bangalore, now Bengaluru. Captain S.S. Gopajkar and First Officer C.A. Fernandez were at the controls. On board were 139 passengers and 7 crew members, a total of 146 people embarking on what should have been a standard domestic flight. The departure from Bombay was uneventful, and the cruise phase proceeded normally. As Flight 605 approached Bangalore's HAL airport, the destination weather was favorable, good visibility, no significant cloud cover, and light winds. Conditions were ideal for a visual approach, often supplemented by the Instrument Landing System, ILS, for precision guidance, especially onto runway 09. An ILS provides crucial lateral guidance via the localizer signal, keeping the plane aligned with the runway centerline, and vertical guidance via the glideslope signal, ensuring a steady, correct descent angle towards the touchdown zone. Pilots typically capture both the localizer and the glideslope signals, and the autopilot, if engaged in the correct mode, like ILS or approach mode, follows these signals precisely down to a decision height near the runway. However, the flight crew of IC 605 made a critical decision during the descent. Instead of configuring the aircraft to capture and follow the ILS glide slope, they selected and remained in the open descent, sometimes referred to as flight level change, or similar, depending on the specific FMS mode for the autopilot. As we mentioned earlier, open descent prioritizes reaching a target altitude at a selected speed, typically with engines at idle. Crucially, it disregards the ideal glide path. If the aircraft is above the normal profile, it will descend rapidly to capture the selected altitude. If used too close to the ground without vigilant monitoring, this can lead to a dangerously steep descent rate and a rapid loss of altitude, putting the aircraft well below the safe, standard glide path. The investigation couldn't definitively determine the exact reason, but possibilities often explored in such scenarios include mode confusion, distraction in the cockpit, misinterpretation of the flight displays, or perhaps attempting to lose excess altitude quickly without fully appreciating their proximity to the ground. Whatever the reason, the reliance on this mode during the final critical stage of the approach proved fatal. As Flight 605 passed the outer marker, the point where the final approach segment typically begins, it was already significantly below the standard 3-degree glide slope for runway 09. There were audible warnings, likely the sink rate alert, followed potentially by the urgent pull up from the ground proximity warning system, GPWS. In these final seconds, realization dawned in the cockpit. The CVR recorded calls for a go-around. The pilot slammed the thrust levers forward to the toga, take off, go around, detent, demanding maximum engine power, and pulled back on the side stick controllers to raise the nose. But it was tragically too late. The aircraft was too low, too slow, and already entering an aerodynamic stall. The wings couldn't generate enough lift to arrest the descent or climb away. At approximately 1 p.m. local time, just 700 meters short of the runway threshold, Indian Airlines Flight 605 slammed into the earth within the grounds of the Karnataka Golf Association course. The impact force was immense. The A320, laden with fuel for its journey, broke apart violently and erupted in flames. The scene was one of utter devastation. Eyewitnesses on the golf course and surrounding areas described a sudden, horrifying impact and explosion. Rescue efforts began almost immediately, with golf course staff, local citizens, airport fire services, and personnel from the nearby Hindustan Aeronautics Limited, HAL, and Indian Air Force establishments rushing to the scene. Their task was harrowing. They faced intense fire, mangled wreckage, and the desperate search for survivors amidst the chaos. Despite the severity of the crash, the fact that the fuselage didn't completely disintegrate on impact allowed a number of people seated in certain sections, particularly towards the rear, to escape or be rescued. Incredibly, 54 people survived the initial impact and fire, though many sustained severe burns and injuries. The final toll was tragically high, 92 fatalities, including both pilots and 2 flight attendants. The crash of a technologically advanced aircraft like the A320 demanded a rigorous investigation. India's DGCA took the lead, working closely with experts from Airbus, the engine manufacturer, IAE, and the French B. Investigators meticulously documented the wreckage, mapped the debris field, and secured the vital flight recorders. The analysis of the CVR and FDR painted a clear, albeit grim, picture. The data confirmed the aircraft was fully functional, with no evidence of pre-impact mechanical failure or system malfunction. The engines responded when commanded to toga power, but the aircraft was already in an unrecoverable situation. The flight controls were operative. This ruled out catastrophic technical failure as the primary cause. Instead, the evidence pointed overwhelmingly towards what is known in aviation safety as controlled flight into terrain, or CFIT. The investigation concluded that the pilot's decision to use the open descent mode during the final approach, coupled with their failure to adequately monitor key flight parameters, airspeed, altitude, and vertical speed, led directly to the crash. They lost situational awareness, allowing the aircraft to descend dangerously below the required glide path at a critically low airspeed. The attempted go-around was initiated too late to avert the impact. While some groups, including pilot unions, initially raised concerns about the complexity of the A320's automation and whether it might have contributed to confusion, the official report firmly placed the cause on the crew's procedural errors and lack of adherence to standard approach protocols. The investigators emphasized that the automation, while advanced, performed as designed based on the inputs it received. The issue lay in how it was utilized, or not utilized correctly, by the flight crew during a critical phase of flight. The Flight 605 tragedy became a significant case study in human factors in aviation, particularly concerning the transition to highly automated cockpits. It highlighted several crucial areas: mode awareness, training, crew resource management, CRM, and automation dependency. In the wake of the crash, Indian Airlines temporarily grounded its A320 fleet, and procedures and training for the type were reviewed globally. The accident, tragic as it was, contributed to the evolving understanding of human-machine interaction in the cockpit and reinforced the safety layers designed to prevent CFIT accidents, which were unfortunately more common in previous decades. More than 3 decades have passed since that tragic Valentine's Day in Bangalore. For the families of the 92 victims, the loss remains profound. For the 54 survivors, the memories of that day are indelible. The crash of Indian Airlines Flight 605 wasn't just a statistic. It was a deeply human tragedy born from a sequence of errors in the final moments of an otherwise ordinary flight. The lessons learned from Flight 605, paid for at such a high cost, have undoubtedly contributed to making air travel safer today. If this deeper dive provided value, please show your support by hitting the like button, sharing this video, and crucially, subscribing to Echoes Untold, where history whispers and we listen. Fact check. The detailed account of Indian Airlines Flight 605, including the specifics of the Airbus A320 systems, fly-by-wire, glass cockpit, the approach procedures, ILS versus open descent, the crash sequence, casualty figures, rescue efforts, and the official investigation findings attributing the cause to pilot error leading to controlled flight into terrain, CFIT, is based on official reports and established aviation safety records. Source: Aviation Safety Network, ASN, Accident Description for Indian Airlines Flight 605, VT-EPN, official DGCA investigation summaries, and reputable aviation safety publications analyzing the human factors involved.